Okay, so in this video, we're going to look at how to sketch graphs of a tangent function. If you're looking for sine and cosine functions, look at the other video with a few examples there of how to do those. I've done them a bit separately because they're a little bit different in terms of their shape, in terms of some features, and in terms of their period. So the tangent graph is a periodic function, just like sine and cosine functions, but the period is only pi over n. So remember the other ones are 2 pi over n, so this is exactly half of those periods. And that's all to do with the unit circle. In the unit circle for sine and cosine, to get all possible solutions for sine and then repeat, it's plus, plus, minus, minus. So you got to do a full circle before they start repeating, before the cycle repeats. Same with cosine, you have positive, negative, negative, positive. So you have to go around the whole circle before the pattern repeats. But with tangent graphs, or with tangent, I should say, it's positive, negative, positive, negative. So it repeats itself in only half a circle. So you got positive and negative, and then positive and negative again. So the cycle is repeating in half the time. Hence it's pi over n. Once again, that n value is the dilation factor from the y-axis. Any tan function has the form f of x equals a times tan nx plus c plus d. As always, this d is your vertical translation. It doesn't really give you any specific information about the graph itself. It just tells you how far it's moved up. This a is your dilation factor from the x-axis again. If it's less than 0, it's also the reflection around the x-axis again. But in this case, it is not the amplitude. We have no amplitude for a tangent graph because the graph goes off towards infinity. So there's no amplitude. Amplitude is when you have a top end and a bottom end, and it stops it. This one just keeps going. So no amplitude. So please do not ever get caught out with amplitude for a tan graph. This value of n here is always this dilation of 1 over n from the y-axis. And it can also be a reflection in the y-axis or around the y-axis. Excuse my running. Once again, to find the horizontal translation, you solve nx plus c equals 0, and you find x equals negative c over n, and that will tell you the value. The negative, if it was negative 1/5 or something, it goes to the left 1/5, it goes with positive 1/5, it goes to the right 1/5. Now with a tangent graph, you have vertical asymptotes. Now vertical asymptotes happen whenever the bit inside tan equals pi on 2, or an odd multiple of pi on 2. So we know that because in our unit circle, tan of 0 and tan of pi equals 0, about 90 and 1 to 70, or I should say pi on 2 and 3 pi on 2, those values are undefined. So we get a value of x here that makes this whole thing equal to pi over 2. Then we have vertical asymptotes. And this is our general shape for a tangent graph. So vertical translation, you just move it up and make it look something like that. And horizontal will move not only the graph, but also the asymptotes with it. So let's have look at a couple examples, and hopefully we'll have a good understanding by the time we're finished. All right, sketch this graph. First of all, let's do the period. Period equals pi over 3, because n is 3. Remember, there's no amplitude in this case, so we're not going to worry about amplitude, but we can see there are 2 periods in here. All right, so find y-intercept, let x equal 0, and you get 2 lots of tan of 0. Now tan of 0 is 0. So we know the graph is going to start at 0, 0, because that's also our endpoint. Which means our graph is going to finish at 0 as well, because the period is pi on 3. So one full period happens and it's going to go through pi on 3 there, and then it's going to stop at 2 pi on 3 there. In this particular case, if you try to find the x-intercepts, that is what you're going to get. Because if you look up here, the shape, there's only one x-intercept per cycle. And in this case, it just happens to be 0 at a period, and you get all the way to the end. You can, of course, solve equations using 3x equals an angle. So if we put 0 equals tan of 3x, tan of what gives you 0? Well, that's 0. We also know it'll be pi and 2 pi. This is using the working domain idea, because you can multiply this thing by 3 to get 2 pi like that. That's what I've got. Then you can divide by 3 to end up with 0, pi and 3, and 2 pi and 3. Go check out the videos and solving equations to see where those are coming from. The last thing I always want to do is to find the asymptotes, vertical asymptotes. Now, if there are no translations, the vertical asymptotes are halfway between the intercepts. So in this case, it's going to be here. Straight up and down through here. That's going to be x equals pi on, well, half of pi and 3 is pi and 6. And this one here is going to be halfway between pi and 3 and 2 pi and 3, which is going to be pi on 2. But let's see why that is. So remember I said the bit inside the bracket had to equal odd multiples of pi on 2. So pi on 2, 3 pi on 2, 5 pi on 2, etc., etc. By the working domain, we said that 3x had to be less than or equal to 2 pi. So 5 pi on 2 is too big. And now I'm going to divide through by 3. So pi over 6, comma, 3 pi on 6, which cancels out to be pi over 2. And that's what I've labelled. Once you've got all that, we draw our tangent shape. Now the tangent shape is vertical, and then it doesn't flatten out like a cubic. It looks a little bit like a cubic, I guess, in one sense, but then it continues on. So it only flattens a little bit. It does not give you a stationary point. Something like that. Making sure your graph goes towards the asymptotes, doesn't start falling away. Make sure it doesn't accidentally slip across the asymptote or anything like that. Make sure you have a nice one straight line where possible. And then you have pi over 3, comma, 0. And that's how we draw the first one. Let's look at the next one. This one, we've got a couple of things happening here. We have vertical translation. We've got a horizontal translation happening in here somewhere, and we've got a negative. So the negative, remember, just means the graph is going to be going down. What really affects things is the translation. So let's look firstly at our x-intercepts. So 0 equals negative tan 2x take pi on 2 plus 1. You subtract the 1, makes it negative 1. Divide by negative 1, and you'll end up with tan of 2x take pi on 2 equals 1. Got to think to yourself, tan of what gives you 1? That is pi on 4. So we end up with 2x minus pi on 2 equals pi on 4. And from here, we're then going to try to find all our solutions. Now, the working domain in this, you're going to multiply this by 2. 2x there, sorry. So we're working between negative pi and pi. So that's the first solution. Now remember, if I add a period, that gives me 5 pi on 4. It's too far. I'm thinking of a period of a graph without the 2 there. That's what we're doing with the working domain. So we're going to have that one, and I'm going to have that one minus pi. So that'd be saying, oh, pi on 4 is there, and I'm going to go back to there because of the negative pi. So we have 2x minus pi on 2 equals negative 3 pi on 4 and pi on 4. And we solve for x. So we add this across. Now this is the same as 2 pi on 4. Negative 2 pi on 4. We add it across, and you get negative 1 pi over 4. And we get 3 pi over 4. And we divide by 2. And there are our solutions. Now, in terms of asymptotes, let's find those. So we know that this 2x minus pi on 2 thing must be equal to odd multiples of pi on 2. So you have pi on 2. We can go up to 3 pi on 2, but that goes outside our working domain. Remember, the working domain was up to pi. That's too far. So we're going to get rid of that one. So it means I must be going back again. In that circle, I've gone to there. If I go to the next one, I've gone past pi. So I'm going to go back to negative pi down there. Negative pi on 2, I should say. We solve for that this time. So 2x equals, we'll be adding pi on 2 across, that's 0. Adding another pi on 2 across, and that gives you pi. Sorry. And then divide those by 2, and you end up with that. So those are my vertical asymptotes, and I'm actually going to have another one at negative pi on 2. We'll see why in a minute, because all the period asymptotes are one period apart. So the last thing I'm going to do before I sketch this graph is to the period. We know is pi divided by this 2 here, so it's pi over 2. So we just found we have a vertical asymptote at 0, a vertical asymptote at pi over 2, which happens to be our end value, which is nice. And they are spaced pi and 2 apart. That means there must be another one back here. Okay, and in terms of our intercepts, it's not going to be nice and halfway between this time. That only works halfway when there's no vertical asymptotes. Vertical translations, sorry, I should say. But this time the graph's been moved up one, so what I'm going to do is draw a horizontal line at 1. And that becomes our new x-axis. And then we know from our new x-axis that any x-intercepts happen exactly halfway between those two asymptotes. So I've drawn this line here, so I know it must go through those two there, those 2 points. I also know it's negative, so I know it's going to be coming from, instead of down here and up, must be coming through up here. So go down through there, like that. Something like that. That probably should be going a little bit closer than I did. It's pretty close, but I'll just do a cheats way for now, which you can't do in an exam, of course, but to save some time. There we go. And on your exam, you would then remove that green line. Last thing, of course, is to label your intercepts. We've got negative pi on 8, which has to be this one here. And that should make sense because if this one here is negative pi on 2, which I haven't labeled yet, then that one's going to be, this value here is half, which is negative pi on 4. This is going to be half again, negative pi on 8. And same thing over here. Halfway between these two will be 3 pi on 8, which is what we're looking for. So that there is going to be 0 and 3 pi on 8 like this. And the vertical asymptote there is going to be x equals pi over 2. And that is how you sketch tangent graphs.